the list. So I created my list.
Yes.
I created my list using the int and the string. I didn't put a bool, but I was using these two just for start.
Yes. Yes.
I was accessing now any item in the list through my
Yes.
formula. For example, this is the first item, index 0, which is 1.
Mm. Yeah.
The last item, which is index 6, was Anthony. So I was changing my items in the list. For
Yes. Yes.
example, I changed 4, which was I changed is it changing? Okay. Yeah. So I was reading the values in my string through these formulas. Now for
Yes.
index 2 and index 4,
Yes.
I learned about now
The
the
for
loop,
loop.
the for loop.
Yes.
This is just what
Yes.
I
Yes.
did. The for loop, I was able to do it.
Yes.
And now the append, I learned
Yeah.
about the append and the pop
Yes.
and the extend.
Nice. 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 Yeah. The methods of
Yes,
working with the list. Okay.
with
That's
the list.
nice. That's
Yeah.
nice. So today I'll show you how you can download that notebook, and you can even share with us in the LMS so that we can
Okay.
also know what you did and we can
Okay.
also learn from you. Yeah.
Okay. I also
Okay.
checked. I also checked on the assignment, the LMS. Though I was not
Yes.
able
Yes.
to easily
To
go through
finish.
it, I was
Mm-hmm.
not able to finish.
Mm-hmm.
Whereby I read my CSV, I was
Yes.
able to identify missing values using the data is null. Um,
Yeah.
and I changed my missing values. The null
Yes.
value is
Nice.
0. So I was not able to put
Yes.
an index, a specific value for them, like the mean, the median. I don't know how to do that.
Oh, okay. Mm-hmm.
Yes. So I checked again
I'll
with the.
share material. Yeah, I'll share material for you to be able to do that. Okay,
Okay.
next.
Okay. So I was able to input all the values. So there was no NA.
Yeah.
So I also learned how to drop the roles that had 0 or null.
Yeah.
For
Yeah,
example,
head missing value because zero usually reference x axis is equal to zero references
to
to
the
the
row.
row data, not that it is containing zero. Yeah. So
Yes,
it
yes.
shows that it is blank. Any row that is blank. Yes.
For
That
example,
has any missing value.
yes. Okay. Row 18 was deleted from here. That's
Yeah.
because it had a null value. It had a null value, so that was dropped.
Yes, yes.
So I was using that formula, and I learned about data types and the
Yeah.
database. Um, so I was not able to use this formula
Yes.
of creating. I was storing a column data as a variable. So this is
Yeah.
something I'm still learning to do. Yes, yes.
Okay, okay. Yeah, that's
So that's
nice. That's nice progress. Yeah, that's really nice progress about almost what we covered the first day, and that is very interesting. So those assignments are very important because they push you to do further research about what you are supposed to learn. So Irene, I don't know what you learned.
Pardon?
What did you learn from the previous class? Is there something that you maybe did to remind yourself via notebook? Maybe to practice, maybe the assignment we sent or something? Hello,
Oh,
Irene.
I
Okay.
I'm yet to do the assignment, but I
Yes,
was
yes.
just first going through the notes from the previous class.
Okay. Okay.
Yeah.
Okay. Thank you. So please go through and I will add more material so that we build good foundation with Python as we go ahead. So Agnes is my colleague and is here with us today. So in case of anything, she will also let me know, maybe in the comment section. You can still unmute because we are in an open environment. You can just unmute if you cannot hear me clearly, or if you cannot see the screen, you can tell me and I will be able to do the necessary to ensure that we are all well. So we are starting our class today a bit late, but we are going to ensure that we push so that we can even extend our class maybe to up to 8:30 if it forces us to do that. So as long as we understand what we are supposed to cover today. So today we are going to cover about exploratory data analysis, and I'm going to start by sharing my screen.
We can't hear you if you are talking.
Okay, so I think you can now hear me. So let me start
Loud and
sharing
clear.
my screen again, because sometimes you may start sharing your screen and you are muted. So is it okay? Is it okay now?
Yes.
Yes, yes.
Okay. So, and you can see my screen. Welcome to session 2, exploratory data analysis in Python. Right?
Okay.
Okay. So, exploratory data analysis, it is very important concept before you carry out. Is there someone raising a hand or something? Just had some background. You can just unmute in case you have an inquiry or concern. Okay. So welcome to session 2, exploratory data analysis in Python. So it's good to conduct exploratory data analysis for us to understand how is our data structured, or what are some of the relationships that we can draw out of data that we have. So the importance of exploratory data analysis includes understanding the data. So it helps us in gaining a comprehensive understanding of the data. So this is a Jupyter notebook, and I think I had not oriented you about how to use it, but I see Godfrey was able to use it. So here you can be able to insert rows above. Here you can be able to insert rows below. Here you can delete a cell. Here you can move your cell up. Here you can move your cell down. Here you can be able to, some of the things you can hover and you see you can duplicate a cell. Here are some, under file, you can be able to create a new file. You can be able to create a new console for a notebook. You can be able to save your notebook. You can be able to download your notebook. So once you download your notebook, you can be able now to share your notebook in an editable form where you can be able to just run. Someone can be able to run. So just download and upload where you want to upload it. Other forms that you can be able to export your notebook are here. If you want to export a notebook as PDF, you can be able to also export it. And those are the backgrounds. You can be able to change the views, how you want to view your data. You can be able to edit, copy, paste, undo, move cell up, down, and other stuff. So you can be able to run cell one by one, cell and insert, run and insert cell, selected cell. So these are some of the things are self-explanatory here, but this is very, very important to know. So it is not good for you to come to the kernel unless it is necessary. So when you interrupt the kernel, it will not be, so your code will not be able to run. So you can restart the kernel in case you have a problem with running your codes, and you can restart and clear all outputs in your notebook. You can also be able to run. You can be able to restart and run up to the selected cell. You can be able to restart and run all cells. So some of the things are self-explanatory here, but the kernel is the brain. It's the brain of Python. It's the core, of the Python. So here are also some of the settings, and I think from there we can be able to proceed. So if you want to highlight maybe this as your first title, you ensure that you put your double hash or single hash, any hash, and then you leave a space between your title, and then you change from code. Here you change from code to markdown, and now you run this cell. You run this cell by shift enter. It will be able to make it capital. And when you want to have small titles like these ones, you use double ***. You just quote ***, and you run it under markdown and not a code. You change this to markdown. So those are the basics of Jupyter Notebook that can keep you going. So I'll proceed with the importance of exploratory data analysis. The first one we said that can enable you to understand your data, where you can be able to realize any patterns, any anomalies, any missing values, any outliers, so that you handle them before doing your data analysis. Data quality assessment, you can assess the quality of the data by detecting missing values, inconsistencies, outliers, and such. Hypothesis generation, so it assists us in generating hypotheses about data, which can be tested later through the statistical analysis and the predictive models. So it helps us in informing insights and guiding the direction of subsequent analysis. So once you do things like you reference your data with D types for checking the data types of your data to know which analysis you can perform to your data is very important. Checking the shape of your data, how many rows, how many columns is very important. Checking if data has missing value is very important. Because some of the correlation hypotheses require that data must be consistent and should be no missing values. So fourth one is informing feature selection and engineering. So after studying your data, you can be able to know which are other columns or rows you can form from your data. That is what we call feature engineering. Which rows can you generate from? Which columns can you generate from your data? For example, if you have revenue and you have cost, you can generate profit. That's what we call feature engineering. So you can be able to you will be able to understand how your data is and some of the relationships that are in with your data. So you can also be guided in model selection. You can know which is appropriate model by understanding the data distribution, the relationships between your variables, and you can choose appropriate machine learning models. Communication and findings, it is very important when you do exploratory data analysis because visualization and summaries generated during the EDA are essential for communicating insights to stakeholders in an understandable manner. It is a simple way of just doing visualization to check how many female, how many male, doing those visualizations. So we'll start today by loading our data into Python. The overview of the EDR process, that is, we start by loading your data. So we learned about pandas. So we import pandas as PD. That's the first thing we do. And the dataset that I'm going to use is the one you have, the one we refer to as restaurant data. If you have that link, and I think I can still access that link, not here, it is in another environment. I think you have it, the dataset for the restaurant. For mine, I am using it. The name is dashboard, but it's just the same data. Do you have it? Please, someone to confirm that. Just check the data we shared in the previous class. If you can hear me.
Yes, it was shared. Hello?
Yes.
It was shared.
Can you share? Can you access the link?
Yes, I can.
Yeah, you can reshare the link, please. let me first of all stop presenting so that we get the data. Once all of us have the data, then we can be able to proceed. So George.
Yes.
Do you have the data?
Yes, I think I have it. It was named dashboard data.
Yeah, if that is the one you have, that's pretty cool. That's what we are using.
Yeah, that's what I have.
Okay. I think it's this one. Let me just post it in the link, post it in the chat section so that you can get that. If you don't have the data is now posted, so you can download it. When you click on the link, it will be able to download, and now we can all have the data. And we start by, let me share my screen. And if you cannot hear me after sharing my screen, you let me know so that I can leave and come back. So can you see my screen? Hello?
Yes. Yes.
Okay.
Yeah, we can see your screen.
Okay, thank you. So we start by importing data. So my data, I'm going to call it DF, but you can give any name to your data. Doesn't have to be DF. We are just abbreviating it so that it can be easier to reference to our data. So our data, we are naming it DF, and then we are importing it is an Excel file. You check at the extension of your data to know which type of data it is. And then you can change here. If it is CSV, you just change here to CSV. So we refer a function in pandas known as read underscore Excel, and then we change, remember to change your backslash to forward slashes. And from there, you will have imported your data. So I'll just run this to import my data, and I can perform some simple data exploratory elements here that we performed last time to check just how is the structure for our data here. To just view the first 5 rows, we use df.head. We see the first 5 rows of our data, and hope you can also, from your end, see the data that I have. Also generate maybe the same. You can check the bottom of your data using the tail, and you can check the information about your data if it has missing values or not by just running the df.info. You will see here how many rows do you have in each data, how many elements, like how many total items do you have, entries in each column. And my data has no null values. And my data types, you can see the data types. This one, objects are strings, so you cannot perform any arithmetic numerical operation on these ones. But on the other ones, you can be able to perform numerical operations except the date. So that's how you can check that using the df.info. You can use the df.tail to check the first, the tail of your data. The tail of your data. You can check the tail of your data. The bottom 5. You can use the describe to check some simple summary statistics about your numerical data that you have. Simple numerical statistics. It even computes including the age. Including the date. So any numerical operation can be able to happen on it. But sometimes we said that we can do subsetting of our data by referring to a column. Maybe we want to just check the profit only, summary about profit only. We subset our data like that. And now we can see the summaries about profit only. The counts, the mean, the STD, and stuff like that. So those are some of the things that you can be able to do with the data. So maybe let me see we can be able to change the decimal, like how many decimals do you want, decimal places about our mean, our mode, our median, our mean, our standard deviation, our minimum value, our maximum value, our quantiles. These are quantiles. First quantile, second quantile, third quantile, the maximum value. We can change that one using the round. So first of all, you start by describing your data, and then you call the round function in R. Then you specify how many rounding off do you want to what decimal places. So you can be able to do that in Python. So these things we had covered. So we said that you can reference to a particular column or multiple columns in R. You can still also reference to multiple columns in R. Let's see if we can reference to revenue. Revenue also. Revenue also. Sorry. Let me include another square brackets. So you must include another square brackets so that you can accommodate multiple columns. You have to include another square bracket like this. And you can be able to select as many columns as you want. So that one gives you the freedom of selecting multiple columns as you want. I don't know if we are together up to that point. Let me just maybe paste this in the chat section, just in case someone was not able to type. Yeah. Okay. You can proceed. So the shape is just to check the shape of our data. The shape of our data, like how many rows do we have, how many columns do we have. Let me just leave just copy without cutting it. So use that shape to do that. So these are some of the things that we did. Yeah, so you can just reference to shape like that. And you can be able to see our data has 7 columns and 25 rows. And you can now check if there is null values, is null, and you count them. You can count how many missing values do you have in your data for each column. So we copy this, we insert a new cell below, and we can be able to explore this. We see that there is no missing value in any column. So that means that even in rows also there's no missing values. In case we have missing value, you can be able to drop the missing values. And we advise that when you drop missing values, please create a new data new variable that reference to that data that you are creating, so that you don't affect the original data. And sometimes you may want to go back to the original data. So we say that if you want to use the drop function, drop missing values, it's good that you reference, you create a variable and you assign it that. So suppose I had a missing value, I could have just taken this. Let me just create a new cell here, paste here. But now I change this to clean data. I can just call it clean data. Suppose I had missing value, so I can give it another variable name, and I say equal to, and assign it this. Now I can be able to run this, and I will have dropped that data in case I had missing values. And when still I do the count of if there is null value, I will get now there is no null values. Using this function, I can run it back. So that's how we do. So you are advisable to do that for you to protect the original data. Suppose you want to fill with the original value the way Godfrey showed us. You just have to define reference to the, you can reference to the column, specific column, or reference to the original, all the data. If there is any missing value and you want to present with everything a unique value, maybe for example 0, just equal to 0. And you can be able to run that, and you can be able to get the value. You fill the value. So you can drop all duplicates in your data. Like in the data that I shared, it has some duplicates. Data on pulse rate, the assignment has duplicates, so you have to clean it out in the data. So you will use this method from pandas, and we can be able to drop duplicates in our data, and you can still check that. So we go to data visualization, which is part of the aim of today. That one was just like a recap of what we covered. And in data visualization and exploratory data analysis, we have different packages in Python that we use to do data visualization. So we will just cover here some. We will cover matplotlib, we will cover Seaborn, and the advanced one, which we will not be able to cover here, is Plotly, but we will just see how it works. So we start by importing the matplotlib.pyplot. So as PLT, that's what we start by. We import this. If you are using another platform that is not Anaconda, you will have to install, first of all, the package matplotlib. We install matplotlib. So you'll say pip install matplotlib, and then you can be able to install it. And then now is when you can now import it with an alias. We say that this is an alias, which enables us to reference to it rather than calling the whole name. We reference to PLT. So anywhere you see PLT in our code, just know that we are referencing to a function in matplotlib.pyplot. And we import also Seaborn as SNS, and then we can be able now to use the Seaborn functions that we have. So for example, let me just create a new cell here. So ensure that we import that. If you're doing that on your end, let me just create here a new cell, and I will put my code here for the Seaborn, the first code, which is on plotting a histogram. So maybe I want a histogram of profit that I made. So this is histogram of profits. Of my profit, histogram of my profit. And now you just call, we said that this is how we subset, we reference to a column in the data that we have. So for profit, you just say SNS histplot, SNS dot histplot. Let me just paste that one. And SNS dot histplot. And now you can be able to see a histogram. Sorry, we have not run this. You have to run. So this is the importance that we need to know. We need to know that anywhere you see an error like name SNS is not defined, that means that the Seaborn has not been imported. So we have to run this cell above first, and then now is when we can run here. It will not have this error. So need to know that that is the importance of installing the packages one by one. So once you install the package, you can now be able to see your first histogram. So maybe we may want to add some title to our histogram. Maybe we want to add the title to our histogram. So you just come here, you say plt dot title. You open the quotes, you put the name you want to reference to it. Histogram of profit. Histogram of profit. Histogram of profit, sorry. Histogram of profit. So that's how we do that. And now when we run again, we can see now we have a title here, histogram of profit. And that's how we do it in Python. And you have just created your first visual in Python, which is a histogram referencing to a particular column in your. So maybe someone to show us that on their screen. I have stopped presenting, so someone can show us that. So this is Seaborn. You see PLT, we are referencing to matplotlib. So some of these things, they relate, they have relationship. So it is easier for you to work with them together. That's why you usually see sometimes someone imports all the packages and now starts writing the program because all the packages are already installed. But now here we have to move step by step. We import a package when we need it to use. So for example, we wanted to use Seaborn and we wanted to use the matplotlib. So there are some charts that you can produce in a particular package, and there are some charts that you cannot produce in other packages. So it is good for you to know which kind of chart do you want and which package will you use to reference to it. So that is the best thing to do in Python while learning about data visualization. So data visualization is important. So I want someone to share their screen as I make some information that data visualization is important because it is easier for you to understand insights from the data visualized rather than the data in the tables and spreadsheets. So that's why it is very, very important. So who is sharing the screen today? Irene, how are you? Can we know if you can be able to share your screen? Irene, can you hear us? If not, I'll allow George to share the screen. George, you can share your screen.
Can you see my screen?
Yeah, we can see your screen. Yeah. Okay, nice. So from the histogram that we have generated, we can even say, no, don't stop sharing. We are
Oh,
using your histogram to make insights from our data.
Okay. Sorry about that.
Okay, yeah, because
Sorry about
the thing is, we are not interested in just generating the visuals. We have to know what the visual is telling us.
Interpretation.
Yes. So from the data that we have, we can see that our data is skewed. So which kind of skewness is this? Which kind of skewness is this? Yes, George. Which kind of skewness is this? Do you remember skewness and kurtosis?
Not quiet.
Yes. Dennis, which skewness is this?
Do you have left skewness? How do you call them?
Yeah, left and right skewness.
Yes.
So which kind of skewness is this?
This is left.
That is left skewness. What do you say, Godfrey?
I have no idea about skewness. Sorry.
Okay. So we usually have other terms that we usually interchange between left skewness and right skewness. So a positive skewness is what we usually reference to right skewedness. So in this one is rightly skewed. You look at where the tail is. Where the tail is what will tell you. The long tail is what will tell you which kind of skewness is. The tail, which shows that if we say that there are outliers in our data, then our outliers are at the higher value. So it is a positive skew because the values that are outliers, that may seem to be outliers, if we check for the outliers in our data, they are on our right-hand side. So we call it right skewed. Right-hand side, the tail. Are we together?
Again?
So we are saying that the data, if the tail is to the right, that means that the outlier exists in the right hand side. The extreme values exist in the right hand side.
No, where is the tail? Where is the tail?
The tail is to your right. The higher
lowest value
values.
Here.
Yes. That one is the tail. We will be able to see if we will be able to plot a density plot. Okay. We will see where the outliers are. So maybe we proceed. Godfrey, are we together? So we said the data can be symmetric. Symmetric, that means that the data is normally distributed. All the central data exist at the middle point or at the center. And asymmetric are of two types, either skewed to the right or skewed to the left. Skewed to the right means that there is positive values that are extreme. Skewed to the left means that there is negative values that exist in the extreme. That is a point to note while dealing with data exploration. So that if there is outliers, you can now conduct more observation to check if actually these are extreme values or are just normal. Are we together?
Yes, yes.
Okay. Now you can stop sharing so that we can now proceed. So if you cannot hear me, you tell me so that I can leave and come back. But I think you can hear me and you see my screen. Can you hear me and see my screen?
Yes.
Yes, we can.
Okay, thank you. So we proceed to the box plot. So box plot, it helps us to identify. It is a 5-number summary. Box plot is a 5-number summary. So we use Seaborn to plot a box plot by creating by referring to our profit data and assigning it to an X. X is just like the data set. So they ask you here about the data set. The box plot function requires you to provide a data set. But now the data set you reference to the subsetted data, your subsetted data. So you plot a box plot using Seaborn. So let's see what box plot will tell us about this profit, if there are outliers or not. So box plot here, let me just put it in the chat so that we can all maybe see it from our machines. So the box plot here shows some extreme values to our right. Some extreme values to our right. So this is a box and whisker. So this one is the minimum value. This one is the minimum value. This one is the minimum value. The first whisker line is the minimum value. The second, okay, the lower side, just immediately after the first whisker, is the first quantile. Do you remember things to do with first quantile, second quantile, and the third quantile? Or 25th percentile, 58th percentile, and 75th percentile. Do you remember such?
Manuel, we may need some time, eh?
Yes.
For you to remind us.
Okay, that's why we are reminding ourselves.
Exactly.
Yeah, so this is the minimum value in our data, the minimum value in our data. This is the first quantile, which we usually call it the 25th percent of our data. There was 25th percentile of our data. And this is the median, which is usually the second quantile. And this is the third quantile, which is the 75th percentile of our data. So this box and whisker, it helps us to check if outliers exist in our data. So this is the maximum value, and any value that is beyond this is an outlier. Any value beyond this maximum here is an outlier. So these are the outliers that made our histogram to be skewed to the right. Are we now together, George?
Yes, we are.
Okay. So we will still see how to get to those outliers as we move. We are going to get to those outliers. What are they? What are the data that are causing outliers? So we will get to that. So we have another type of plot which we call a scatter plot. So the first plot is a univariate analysis. The first plot we have created histogram and the box plot is a univariate analysis, which means that we only observe one variable. We only observe one variable. Uni means one. And now we proceed to the scatter plot for bivariate analysis. So we start our bivariate analysis here by looking at our scatter plot. Maybe we want to see how revenue and profit are correlated, are related. How is revenue and profit related? Chart section for the same. So we use Seaborn, we reference function in Seaborn, which helps us to plot a scatter plot, which is called as scatter plot, then into bracket, the x-axis, we define the x-axis to be the revenue and the y-axis to be the profit. And now we reference to our data. Our data, we named it DF. So you can change it to the name of that you maybe gave your data. And we can run this first of all to see our scatter plot. And this is the scatter plot that we have. So scatter plot, it usually shows us the strength of the relationship between the two variables that we have in the analysis, between revenue and the profit. So scatter plot will show you three kinds of output. The first output is this one. From the bottom corner of the left to the top corner of your right. That is what we call positive relationship. Positive relationship. So the strength of the relationship will be determined with the position of the observations. When observations are at this point, this line of observation, these data points are lying on this line here, down here. That one shows that the relationship is weak. The relationship between profit and revenue is weak. If it tends to be strong, going upwards like this, that means it is strong. The strength increases as it moves upwards. The strength reduces as it moves downwards. So remember, as it moves downwards, this one also moves upwards, which now will lead to negative relationship. When this comes until it is equal, this one comes downwards and this one comes upwards until it is equal. You see? Once it reaches an equal point is what we reference to as no relationship between our variables, a horizontal line. And then when the bottom line tends to go upwards to the left top corner, and this one will go to the bottom right corner, we call it negative relationship. That is how the scatter plot is interpreted. So you can know if the two variables have a strong positive relationship or strong negative correlation or relationship or association by looking at how the data points are distributed in the line. Is that okay? Is that clear about profit and revenue? In normal cases, we usually understand and interpret that as revenue increases, because revenue is the x-axis. X-axis or the x is usually refers to the independent variable. So as revenue increases, the profit also increases. That's how we interpret this. As revenue increases, profit also increases. So profit is the y-axis. Is that clear? Is that clear?
Yes.
Okay. Thank you. We proceed to further univariate analysis of our data. So in the previous class, we learned about the value counts in Python. So we subset our data. We use the dot value count, which is a pandas method. And then now we add a plot onto it for us to visualize. So let me just create a new cell somewhere. And I just do the value counts for the country, just here. Yeah, the value counts. So we see there is 105, 105, 105, 105, 105 everywhere. So that means that evenly distributed. So suppose we want to say a bar plot of these values. We add plot into the bracket. Kind, we say bar plot. So, and then we use plot.show. So we said we can add titles to our plots, referring to the matplotlib plt dot maybe title. We can give the title to our plot, title into bracket. We open the quotes. We say bar plot, bar distribution of country distribution using a bar plot, country counts. So these are just counts, so they don't make that much sense. Country counts using a bar plot. So like that, and now when we plot our bar plot, we'll have that title. So that's how we plot our bar plot, and you see they were all to 105, 105, so they are equal. So we can change this to a pie chart as well by changing the kind to pie chart. Pie, we just change it to pie. I will be able to share this also. So you can change it to pie and you can be able to see they are still all equal. So let me just return it back to bar plot. So bar plot and pies are usually used for categorical data, the univariate analysis that we see here. So the categorical data, we make use of bar plot and the pie charts as well. So let me just take this to the chart section so that we can also produce the version of the same. It's just straightforward. We have not complicated our codes yet. So we are just having simple statements on how to produce these charts. So that is straightforward. We just add plot because we imported matplotlib, and now we are referencing it here to show a plot and the kind of plot. So that's how we do the value counts as methods for the univariate analysis. Sometimes we used this. I think I can remove it here. We already have it at the top. So bivariate analysis, or sometimes multivariate analysis. Bivariate means 2. Multivariate analysis means more than 2. So the correlation matrix, we want to plot a correlation matrix. What does a correlation matrix mean? Can someone try? What is a correlation matrix? What is a correlation matrix? Yes, George.
Maybe when you want to find out the relationship between two variables.
Yes, the relationship between more than 2 variables. Now we form a matrix, more than 2, because we looked at a relationship between 2 variables, and we were able to see a scatter plot can be able to give us that. But what if we need to see relationship more than 1 variable, or more than 2 variables? We make use of the matrix, the core matrix. So what we are doing here, if you remember, we started by learning about how to select columns, how to select rows using the lock and iLock. And I said that we should practice on that, because you see we are just building on what we already learned. So lock and iLock. So here we are using lock. So we start by creating a variable core matrix, which will store our data that we are subsetting from the data called df that we imported. And then lock, and now lock, now we open, and then we select all the rows. This one select all the rows. This full colon select all the rows of our data, comma, and then we open a square bracket. Now we select the columns that we want. You select columns that you want. If all your data is numeric, there's no string into your data or categories into your data, you don't have to subset your data. You can just reference the entire data without calling some columns from out of it. So for me, our case, we have country into our data, which is not numeric. Country, and I think there is another variable as well that are not numeric in our data. So we may not be able to carry out relationship of all the data that we have. You remember, country, we have product as well, country and product. So you cannot be able to do correlation matrix on those circumstances. Let me just check where we are. And we are done there. We are here. Correlation matrix. So we reference to the column that are numeric, which we call the integers or the floats. And then we call the curl function. We call curl function from our plots. And now we can be able to get the correlation value. The correlation value for all these our variables that we have. Now we use Seaborn to create a heat map of our correlation matrix. We use Seaborn to create a heat map of our correlation matrix. We use Seaborn to create a correlation for to create a heat map of that. So while using Seaborn, you call your data that you created here, this data that was created from the correlation values that we obtained here, we call it, and then annotation enables us to add the true values, the values of each plot. And then CMAP, we are going to see that. Let me just run without CMAP, and we'll bring back the CMAP, and you will see why we need this. And even the annotation, we make it false and see if we will have difficulty in interpreting our data. So this is false, and we run. So this is a heat map of the correlation matrix. So this heat map, we have dark colors here, which means there is all our variables are related. All our variables are related in a positive way, where the values ranges from 0.75 to 1.00. Let me see if we can create, if we can, okay, let me first of all explain this, and then I'll try something else. So up to there, we see there is a color scale here. So this shows that as the color moves from the dark to light, the strength increases. The strength increases in that way. So that means that when we check at costs and unit sold, cost and unit sold, the relationship between cost and unit sold, it is 0.75. 0.75. It is positive, yes, but it is not that strong compared to the relationship between, where we have light colors, like here, revenue, relationship between revenue and profit, relationship between revenue and profit. We are going to see the values in here. That's why we have here to make the annotation true. When you make annotation true, you'll see the true values of the correlation matrix. So we make true, and you see now it is telling us these colors. What does this color stand for? One stands for a strong relationship, which is light, very strong relationship. 0.8 is not that deep. It is, I think it's deep maroon, and then this is lesser maroon. I don't know, I'm colorblind. Yeah, but when you look at this one, it's deeper compared to this one. So as we move from black to a deeper, another deeper color, and then lighter, and then lighter, and then lightest, lighter, and then lightest. So we can be able to use that. But if we struggle interpreting using this, that's why we have another method we call full warm. And we will see how easier it will be while interpreting this data. So we add that and we run. Yeah. There we go. So can we easily, you see now there we can easily interpret our data. And we see that red indicates very strong relationship. And deep blue indicates weak. Weak, though it's positive, but it's weak in terms of our context here. So that means that the relationship between unit sold and cost of what we said in the previous one, that it is not that strong compared to the relationship that we can have between revenue and the profit. And that is the reality. And that is the reality. Any question about the correlation matrix? You can have it there and also see if you can be able to have that on your end. Any question on the correlation matrix? Hello, are we together or I am alone?
We are together.
Let me see if someone produced that chart. So let me just stop presenting.
If you look at mine, hello?
George, we can see your screen.
Oh, I thought you can't even hear me. You can't see my screen.
But you refused to buy me. No, we were watching. We are trying to come up with the search.
No,
You
can you see
can
my
still
screen?
share. Yeah.
I'm sharing now.
Oh, yes, we see.
Okay.
Yes, nice, nice. We see your screen.
Now,
Yes,
Manuel, yours,
yes,
it never showed all the values inside.
yes, yes.
Yeah.
There's no problem with that. It actually depends with the version of your Jupyter
All the
notebook.
version.
So
Oh,
yeah,
depends
so
on the
there's no
version.
problem. Yeah, but
Okay.
we can still interpret because mine is giving the legend. The legend. Yeah, mine is giving the legend.
Okay.
Let me show you.
Yes. Now we can proceed. That's nice. So are we all together? Are we all together? Do we understand now that? Agnes, Agnes, do you have a question? I see you are unmuted.
No,
Okay.
I was talking to George when you left.
Oh, okay, okay. Yeah, you can mute. Okay, thank you. So we proceed. I share my screen again. Godfrey, is everything all right? Godfrey, is everything all right? Godfrey, if you can hear us. Maybe we will know. If you are back, you let us know, Godfrey. Oh, was out. Godfrey.
Yes, yes. I lost my internet a bit.
Okay, but is everything all right? Have you seen our heat map?
Yes, yes, yes.
And you are also able to have the same?
I still don't have the code. I was lost
Okay,
when I
okay.
was,
Okay, okay. Let's see that. Yeah, our friend here, George, shared the screen about his visual, his heat map. And now you have the source code there. You can also try to see if you can interpret the scale. So we said that our aim is not just getting the plot. Our aim is to make informed decision out of the plot, right? So if you can hear me, we are going to outlier detection. Remember, we identified outliers using the box plot. But now how can we know that where are these outliers? What are they? Where are they? Where are the outliers? Where are the outliers? So we are going into that. We are going into that. So Outlier detection. Identifying outliers we are using the method of interquartile range. We are not going to use z-score because you will research on the z-score because we may complicate the scenario here. But you can research on z-score. There is also another method using z-score where you have to get the threshold and be able to use the threshold to identify values that doesn't reach a threshold value. So we said while plotting a box plot, we said we have first quantile, you have second quantile, and you have third quantile. So first quantile is referred as Q1. Second quantile is referred as Q3. So first quantile, we said is the 25th%, 25th%, and third quantile is the 50th%. And now, remember we are computing the profit. We subset profit, we select the column profit from the data frame, the data we have, the data we imported. And now we use the function known as quantile into bracket, the quantile into bracket function. We give the value to compute the first quantile, which is 0.25. We compute it. And then we compute the third quantile here, which is 0.75. We compute it. And then we get the interquartile range, which is usually obtained by taking the third quantile minus the first quantile. This is just like an arithmetic operation. And then from there now, we say that any value that lies outside, any values that lies outside this is how we identify outliers. In theory, we usually compute it like this. Actually, these steps are the theoretical steps of computing it. But now you see, we are here also computing it using the same theory, but now it is going to help us a lot. So we start by creating a variable outliers. We say equal to, and then we reference to the entire data, the data that we had, which is the DF data we imported. So from the DF, we are looking for values in the selected column, the column we select, which is profit, that will be less than, the lower quantile. The lower quantile, there are some section that we compute using 1.5 times. Let me just post this code. Maybe I will be able to use annotation on my screen when someone else is presenting. Let me see if we will today practice using the annotations in the meeting here to be able to practice. So I want someone to present that code on his or her screen, and then we'll be able to explain. It's not that one. Let me check the one I'm supposed to use. Yeah, I think it is. Yeah, it's just that one. Not that one. Let me just copy the top one, and then we can be able to visualize that. I think I will practice here to use the annotation. Yeah, so you can just have the message there. So once you have that, you share your screen. I'll use the annotation to show us that, if I will be able to indicate. Who is ready to share the screen? Godfrey, can you share yours?
Yes, I can share. Yes.
Okay. Share, please. So in the theoretical computation of, can you zoom out? Nice. So in the theoretical computation of, let me see where my annotation. So I'm the one who can use the annotation, and let me see. I don't see my annotations again. So that means I cannot be able to explain while you are presenting and using the annotation at the same time. So I'll just have to, so let me just explain. Maybe I'll have to share myself so that I can have access to the annotation. Sorry for that, Godfrey. I wanted to use the annotation to be able to just show us the theoretical part, but no problem. We can be able to resume presenting. Okay, hope I'm the one who is presenting now. And if you can see my screen, so here we usually compute the lower bound of our outliers by subtracting. You see here, we take the interquartile range to get the lower bound. Let's say lower bound. Lower bound. This one is not a code. This one is just an explanation. So lower bound is equal to interquartile range is equal to Q1 minus interquartile range multiplied by 1.5. This 1.5 is from the mathematical background. It is not something that is you can change here to something else. It is from mathematical background, so it's a constant. And you compute your upper bound. You compute your upper bound. So you compute your upper bound, which is Q3 plus Q3 plus 1.5. I think someone requested to be added to the meeting. Let me add the person. Okay. So you compute your upper bound using Q3 plus 1.5 asterisk IQR, which is the interquartile range. So you see, so this upper bound, so any value that will lie, so this part, all this part, okay, this part from here to here is the lower bound. And this part from here to here is the upper bound. So any value that will lie in the lower than or less than the lower bound will be an outlier. So we are comparing the lower bound and the values in the column profit. And then we are also comparing the upper bounds and the values in the profit. So we are saying that if the values in the profit are less than lower bound, or the values in the profit are greater than the upper bound, then they should be considered to be outliers. So have you understood that story? Hello?
We are following.
Yes, yeah. So that's how we identify outliers in mathematics. So we just compute the first quantile, the second quantile, first quantile, third quantile, and then the interquartile range, and then we compute the lower bound, we compute the upper bound, and then we compare values with the less than or greater than the upper bound and the lower bound. Now we get them as outliers. So that value is what we call outliers. So let me remove this and run my code. Let me remove this first and call the outliers to check if the outliers will be listed here. Outliers. So these are the outliers that we have. These are the outliers that we have in our data. These are the outliers that we have in our data. So remember, we are using DF to reference to the whole data. That's why when we call it back, it returns all the data that is containing outliers in the original landscape. And now once we have seen these outliers, we visualize the outliers again using the box plot, the way we visualized before. It's just the same way we visualized before by also adding a title here. And now we can run it again. So you see, these are the outliers, the ones we have just seen in the previous code output. Have we understood? So outliers are extreme values. So in most cases, when you're doing analysis and you want to make a decision, it's good to do away with the outliers for you to make a decision. Maybe, for example, you want to look for the average profit, and some of the averages, like means, some of the central tendency values are usually affected by the extreme values. So that's why we are usually interested in identifying the extreme values and removing them, so that when we make a decision out of the data, we make a well-informed decision without being affected by the outliers. And even while making the relationship, for example, maybe you are building a regression model, regression analysis model, you have to check for the outliers in your data, because all these models, like the regression model, some of the models, they are also affected by the outliers because they rely on individual data points. That is something that you should note. So the other part here, is how to drop the outliers. So remember, we did some other parts above, and now here we want to drop outliers by first of all selecting all. We are referencing. Remember here, this is how, because this will also be handy when you'll be working with your assignment. So we use df.select underscore d types. Include, we use numpy here, np numbers, to select columns in our all data that are numeric. This one is basically selecting columns in our data that are numeric. Selecting columns in our data that are numeric. So, and we are assigning that data to a new variable known as outlier data. That data that we are subsetting, we are assigning it to a new variable known as outlier data. And now we are creating a function. Here we are creating a function. Let me share this. We are creating a function. Remember, we said that df is used to create a function in Python. df is used to create a function in Python. df is used to create a function in Python. So we create a function. So it is df. So we give it a function name. Is df, which is a keyword. Then we use a function name, which is drop outliers IQR, which is the interquartile range. That is just a name. You can give another name that you want, and it doesn't have to have the underscores because it's just a name. You can just because remember we said when giving variables, there are rules for naming variables. So you follow just the rules for naming variables and you create your own variable. You follow the rules of naming a variable and you create your own variable. So we define the function. We give a parameter, an argument. An argument is the data that we have subsetted. And then we use the full colon to perform indentation that this is a function, to tell Python this is a function, though we had used def. And then now here we are assigning values. Q1, we assign it a value. We had that before. Q3, we assign it a value. Then Q interquartile range is the difference. And then what should be returned when this function is called? What is it that should be returned when this function is called? So when this function is, it should be able to return. It should be able to return to do here some computation, some Python arithmetic. So remember we had such like computation before. We are checking if any value in our column, is containing outliers. If there is any value that is in our column is lying below or above our lower bound and upper bound. And then we will remove that. We will remove it. That function we have created, we are calling it here. And then we apply it to this data. We call it to apply to this data so that we can drop the outliers and remain with a new variable, which we call it df no outliers, that will be having no outliers into it. That is the explanation of this code. So this part is just what should be returned when this function is called. And it is just performing here an arithmetic operation. Some of these things we just saw them, only that we are changing outlier data with the df profit. And now dot if any, we are checking axis is equal to 1 because we are referencing to check in the columns. And then from there, if that exists, because remember outlier should be column wise in each column of the data, because each column is a feature. And now from there, we drop those outliers here by calling that function, and then specifying the data that we want to drop the outliers. And then from there, now we assign that data, new data that is clean without outliers, to df underscore no underscore outliers. So after doing this, numpy, so we have not installed numpy, so we create it here. That's why it's good for you to run and check if you have the packages. So import here numpy, import numpy as np, import numpy as np. So when I run the numpy first and then come and run my code here, so it is okay because numpy is now installed. So you install numpy as np. So let me take this also and put it on at the top here so that you can be able to run, and you will have settled that numpy necessary variable. So we are running this, but sometimes people prefer just installing all the packages that they will use. But for us, we are learning. That's why you have to run and miss the package and now import it. And now when you run, your code will now work, and you will actually know why people do install, because you realize that in the beginning of all Python codes, things are just import, import, import. Now you wonder what are they importing. So that is it. So once we have created this data set, we want to visualize this data set again to check if we dropped the outliers, because this data is now clean. Now we run again the box plot. We run again the box plot. We run again the box plot. So this is the box plot. And now we can consider the values that are here, that they are not outliers, actually. They are not outliers, because we have computed the lower bound and the upper bound. So as much as the values that we have may be greater than the maximum value, the maximum value, the max value using the max function, these ones are not regarded as outliers because we have computed and dropped the outliers. If you compare these values and the values we had here and the values we had here, you see, there's a big difference. Now the values that remained here cannot affect our results, and we can rerun everything based on that data, and we can be able to see how the relationships are going to change if we have to use that concept. Okay. Now we had an exercise. When you want to create feature engineering, is where you want to create new features, which are variables or columns based on existing columns. So I think there's assignment on that. So this is how you can subset columns and maybe do some mathematical operations onto it to create new columns. So you can reference to this when you want to do the assignment that you had. So the assignment that is there, you need to perform things to be performed at the top using financial data. This one, I think you have it also already. We had it last time. So we are going into the advanced concepts of data visualization. And this one, we will have the assignment, of course, more detailed assignment down there, which will also include this assignment here. So we are going to the in-depth of data visualization. And we started with the importance of data visualization is that we can be able to make informed decision by looking at our dashboards, looking at our visuals, and make insights out of it. So you have to set up by doing the installation of the packages that you'll be using. For us, we have already installed all the packages except the Plotly, which is an advanced data visualization package in Python that will not be able to cover in this concept, but we will show you how it works. So matplotlib basics. Remember, we have been using matplotlib. So the basics of matplotlib, we start by importing it. We have already imported it. So I will not be able to import it again. You don't have to import it again. You already imported it. So we create a simple X values and simple Y values, and then we plot a line plot. This is a line plot in Python, how to create a line plot using data, raw data that you enter yourself. So I'll just explain line by line. I'll explain line by line about this. So we created a variable with the list, another variable with another list, numeric list, and then we call a plot from the PLT, the matplotlib. Matplotlib. PLT. We call PLT plot to plot this. So when we remove this, let's remove this and try to see, because we have not said. Now there we go. We can be able to see our skeleton of our plot. Skeleton of our plot without title, without labels. Now we add the title, we add the X label, we add the Y label, and we say show. So when we can be able to, let's remove this. Let's remove this. So we have added a title, and again, we can return and add X-axis, add Y-axis, or run everything and add dot show, so that we can see everything all at once. So that's how we create a line plot in Python. That's how we create a line plot in Python. But we are not going to use this concept. Is an advanced concept, so we are going to use it. We are not going to use it because it allows you to create. It's an advanced concept, but you can also be able to learn. What it does is that it partitions this concept. It partitions your screen into 4 dimensions. The first dimension is into 4 planes. 4 planes. So the first plane is on the coordinate 0, 0 axis, which is this one. The second plane is, okay, this one now plots the line plot of the variables that we created, the 2 variables we created, lists. And we are using all this using the subplot from the matplotlib. A subplot from subplots from matplotlib, a 2x2 subplot. And now we are partitioning this 2x2 subplot that we created. So that's what is happening here. And we first create a line plot from matplotlib by just calling plot. And then we create a scatter plot by calling scatter from matplotlib. We are creating a bar plot at 1, 0, which is here, bar plot x, y, because these are numeric values. And then we create a scatter histogram. This histogram does not make sense at all, but because we are just learning, we can be able to have it. Histogram requires that you provide only one row, one variable of your data, because it's univariate. And then we say show. So this is a matplotlib. This is matplotlib. And this is an advanced concept if you want to view all your things in one place. But if you don't want, you can just do the normal way. So I can just also give you so that you can also explore more on it. Maybe you may need it in the future while doing analysis of your data, depending on the problem you'll have. So we explore some parts of Seaborn for statistical plots. Parts of Seaborn are statistical plots. We have learned about histogram. We have learned about it. We have already used it. We have already imported Seaborn. So I will not be able to import Seaborn again. But I can just leave it there, no problem. It will still bring me the results. This is a histogram, we learned it. This is the original data that we had not subsested. That we do not clean the outliers. Remember? Suppose we reference to the data that we had cleaned outliers. I think we had called it do no outliers. I will just check the name. Let me just check the name for that data. And then we can be able to see how that histogram will be like. DF no outliers. Yes, DF no outliers. DF no outliers. DF no outliers. So we are going to assign that data here to our matplotlib, and we see if we dropped the outliers, how will our histogram look like? How will our histogram look like? Let me just paste this also, the chat section. How will our histogram look like? So we run this again. You see now, there is no long tail. There is no that long tail. And actually this data now, you can see that majority of the observation. So it is not that skewed extreme as it was. Though it is still skewed, it's not normally distributed, but it has no outliers. Yes, that's how we're supposed to say. It is skewed, yes, but it's not, doesn't have outliers. So we can actually rely on this to make a decision. We can rely on it to make a decision. Another type of plot in Seaborn, is the density plot. Density plot in Seaborn. And this is how we reference to it. KD plot, data is equal to DF, X. X, we are now referring to the variable we are assigning the data from the data frame. We assign the data X, because this one is also a univariate. Univariate, which means that is a single variable data. And now we can visualize this histogram in terms of a density plot. We can visualize that histogram in terms of a density plot. You can see now, you can see the skewness. You can see the skewness in depth. You can see the skewness in depth. You can see the skewness of your data in an in-depth way. Let me just share that. This is just a KD plot. So depending on, you can explore more plots. There are a lot of plots. Depending on the problem you have, you can learn more on how to develop other plots. But the idea is as simple as we can see. We reference to the type of plot. We say data is equal to, we assign it to the data set, and then we refer to which column do we want to plot. If we want to plot revenue, we can just change this to revenue and be able to run again. And we see how the revenue is. If we want to call costs, we just change this to cost, and we can see how cost is. So that's how these things work. So I'll just return this to profit. And how this thing work. That's how this thing work. That's a density plot. If you want a categorical plot, for example, a box plot, again, or maybe this is a multivariate box plot. Multivariate box plot. For example, you want to see country, each box plot for each country based on profit. We use Seaborn. We are using Seaborn.boxplot. Seaborn.boxplot in the chat section. Seaborn.boxplot. We are using Seaborn.boxplot. And then we assign x-axis is the lower or the horizontal axis. We want to see countries on the horizontal axis, and each country we want to see its profit as a box plot. so that we can even check which one has outliers, which one does not have outliers. Like this one. Now we can see each box plot for each country. So this one tells us which country has higher, experienced some anomaly, an extreme profit in some observation. Maybe it was the entry, or maybe it is true. Yeah, and we learned on how to subset data to deal with outliers in our data. We have other ways of also dealing with outliers. We can learn more on how to do outliers using transformation. And you can learn other ways of dealing with outliers rather than dropping the data. Sometimes you may still want the data. Or you can use other methods that are not affected by individual data points if you are doing analysis, making your decision. So this is how we create that box plot for multiple box plot in one plot, as just simple as that. So we have Voin plot is also another type of plot. It's a very interesting plot, but it's difficult to interpret. So it's good for you to use the easier plots. Don't use complicated plots that you may not be able to interpret while making a decision. This is the Voin plot. This is the Voin plot. This is the Voin plot. So Voin plot is actually difficult to interpret. As you can see, it is already difficult. So let me also share with you, this is from Seaborn. This is from Seaborn. You can see, you can have it on your plot and also see how it is difficult even in your eyes to interpret. So we will go step by step. Maybe I want someone to generate for us this Voin plot, and then we can be able to interpret it from someone in the call. I'll stop sharing. Yes. Someone to present to us and then interpret for us the Voin plot. It is very nice plot, but you have to know how to interpret it. So just share your screen and then I'll be able to interpret it. As we finalize, who is ready to do that? Irene? Godfrey?
Yes, I can share.
Okay, please share your screen. Okay, nice. There we go. So this plot is a very complicated plot that I will not recommend you to use it while presenting to people unless you will explain to them what the data is saying. So the first thing, we start with the shape and the spread. We look at the shape and the spread. Actually, this data is made from density plot and box and whisker. Box and whisker. Box plot and density plot. That is the origin of this data. Density plot and box plot. So the width of the violin at different points indicates the density of the data. It indicates the density of the data. For example, you can see where the density, you see it is like a pot. So where a lot of content is, where a lot of observation are found, where a lot of revenue is, the central point of the revenue. For example, you can say maybe from 45,000 to maybe 12,000 on average is where majority of the country's revenue lie. You see where the density is, where the stomach, the stomach of the violin plot is, that's where the majority of the observations lie. So that is the way it indicates the density of the data. So the wider the sections represents a higher density of the observations. So the more you have a wider stomach, the more it means that a majority of that data for that particular country lies. And then from there, we look at the height. So the overall height of the violin plot shows the range of the data. The range of the data. So the longer the plot in terms of height, the higher it has number of observations. And some of the observations may be outliers, though it is not good for detecting outliers. But it will tell you that actually you need to check for outliers, especially for the observations that have long tails to the top or to the bottom, depending on the circumstance of your visualization. And that is the height. We go to the central tendency, the median. So the white dot that we see there in our plot is the median of our data, is the median value of the data, which is the central value of the distribution. That's white dot, the central value of the distribution. Variability, we are now looking at the interquartile range. So that thick bar, the box, what we say this built from box plot and the density. So we see a box plot inside. So that the box part of the box plot and whisker is what represents the interquartile range from the lower interquartile, because the way we interpreted the box plot to the from the first quantile to the third quantile, the box in between. So it's also showing the middle 58% of the data. It is also showing the middle 58% of the data. That box shows the 58th percentage range of the data. And then the whisker, which are the extensions of the box. The whiskers extend to 1.5 times the interquartile ranges from the quantile. The way we did the multiplication, indicating the range of the bulk of the data. It indicates the range of the bulk of the data. How bulk is the data? So you see, one picture can talk a lot about the visual. And then now we proceed to the distribution shape. So a symmetric shape of violin indicates a symmetric distribution. Asymmetric, we are looking at the density, the sides. We are looking at the sides of the data, of the whole shape. If there are no tails, no long tails, shows the symmetric kind of the data, if the data is symmetric or not. If there is symmetric view, when you look at the view, you see this symmetric, that shows that the data is symmetric. Or else the data is skewed. To the left or to the right. Positively skewed, majority of these plots are positively skewed. And then thickness. So thickness of the data usually shows multiple modes, like the common appearance of the data. How big is the data? So that is how we interpret the violin. Explore more about it. You can research more about it and also see how you can be able to interpret it. So we can proceed to, we can stop sharing now, Godfrey, and we proceed to our final session, final parts of our session today. You can just stop sharing. Thank you so much, and I will share my screen again. So we are looking at relational plots. We have learned about scatter plot, which is a relational plot, which shows the relationship between two variables. We did that. using Seaborn, and we saw the relationship that exists between revenue and profit. So while during exploratory analysis of your data, exploratory data analysis, you can be able to know which variables you can check for relationships. Maybe if it is something like a line plot using Seaborn, we looked at line plot using matplotlib. So this is using Seaborn, where you can check the debt and revenue trend in terms of debt and revenue, and it will show us the lower bound and the upper bound. This is Seaborn is showing us the lower bound and the upper bound. This is the upper bound, the shadow, and this is the lower bound. Like in this particular date, we expect a value. Is like doing a prediction of the lowest value that we can expect on that day, and the upper value that we can expect on that particular day. So we can also still explore more. We have already done heat maps, but we can still run this to check the correlations. We have done this. We have done this before. Oh, I think I'm not sharing the line plot. I've not shared the line plot. I think I've not also shared the code for the relationship for the scatter plot. So that, but we already have it. We had it already. And these are just building on the knowledge that we already know. These are just building on the knowledge that you already know. Oh shit, why am I stop sharing? Let me share again. Yeah, navigating between different. Yeah, so that's the line plot. That is so this is a heat map. We already looked at it. This is selecting columns that contain numbers only, numerical columns from the data. And then this one is now plotting the correlation matrix between our data. We said we are using the color scale to be able to make a decision out of our data. You can also look at the values, to help us know which color, the strength of the color, if we cannot be able to look at and interpret the color scale that we have down there. So these things we have already covered them. And we proceed to the advanced data visualization, which I said we will not cover here, which is the matplotlib. So this one we must say it is a markdown. This is a markdown. Yeah. And now we import plotly.express from plotly as px. This is an advanced visualization. You will see how it plots. It is visuals in a different way. So we are not teaching this one, but you can still research on it and see how it works. So it is taking some time to generate some plots here. So this is a scatter plot, the same way we had it in the Seaborn. But now you see it is interactive. It's an advance. You can use it to build Python dashboard. Someone can be able now to hover and be able to see more information. You can even add here more functionalities that you can even add other columns that when you hover here, you can be able to see more information about the cost, about the units sold that are not here in this hover. So this is the interactivity of the plotly in Python. It is advanced. So you can learn, first of all, the matplotlib and the Seaborn, and then you can now come to the plotly. And another thing also in plotly, and this is the final one, but it is not that quite good visual, but it's also interactive. You can be able to hover around and see. So it's about the cost, the country and the profit, each country and its profit. And when you hover around, you see different values for each country. So that marks the end of our today's class and some of the best practices in data visualization is to ensure that you choose the right plot, right type of plot based on the data that you have. You need to avoid misleading scales, especially the visuals that you are not conversant with, or that may bring problems to people who are going to interpret. You need to avoid them. You need to ensure that the readability and clarity is of high order. And then now we have a practical here task, which is the assignment of today, based on this data set that you have, which is financial data, but you will get this material in the learning management system, and you will be able to do this assignment before we meet next week, God willing, about Python. But tomorrow, God willing, we're also meeting for R, for those people who are doing R. And then on Friday, we are meeting for Excel. So ensure if it is Excel, you submit your assignment for Excel, the assignment we gave before then. So up to that point, I'll stop sharing. And